Hi, good day everyone. So again, I'm here today to discuss a video or a topic in general mathematics, specifically functions. Functions are already discussed when you are in junior high school. To be more specific, quadratic function, polynomial function, linear functions, and for this day, we are going to reinforce what you have learned in your junior high school. So our objectives are, for this video, you must represent the real life situations using functions, including piecewise functions. Second one is to evaluate a function. So how are we going to evaluate a function? That is the second one. The third one is we have to perform addition, subtraction, multiplication, division, and composition of functions. In other words, we must perform operations on functions. And lastly, we have to solve problems involving functions. To begin our discussion in function, let me present ceiling function. So this ceiling function will be used later for our problem, so or that is why I'm presenting this. So we have here the ceiling function of a real number x, denoted by that symbol, is defined as the smallest integer which is not smaller than x. So for example, the ceiling function of the decimal 2.31 is 3 because the smallest integer not smaller than 2.31 is 3. In other words, you're just going to round up whatever number it is if it involves decimal numbers or a fraction of a whole. Say for example, the number is 4.5. Its ceiling function will be 5. Say for example, the number is 0.1. The smallest integer not smaller than 0.1 is 1. So that, or we just round it up to its nearest integer. So now, it only tells us that if we take the ceiling function of a number, we're just going to round it up. But if the number is an integer, the ceiling function of that number is the number itself. So we have here a problem. Okay, based on the problem, uh, she will ride a jeep to go to SM Dasmariñas. So, Maria rides a jeepney to go to SM Dasmariñas, which is 8 kilometers away from her house. The fare rate is 9 pesos for the first 4 kilometers and an additional 1 pesos and 50 centavos for every kilometer or a fraction of it thereafter. So we are going to construct a mathematical model from this situation, or we must produce a piecewise function that represent the fare given the number of kilometers. So I have here a table. So let x be the number of kilometers and f of x will be the fare. And if we're going to take a look at the table, so we have here the kilometer is greater than 0 but less than 4. Okay. There are no additional kilometer because there will only be an additional kilometer if it is beyond 4. So if that is the case, for the first 4 kilometer, we have the fare as 9 pesos based on the given. Now the question here is, how many additional kilometer are there in 5 kilometers? If your answer is 1, your answer is correct. So 1 is the number of additional kilometer if the number of kilometers is 5. So we are going to multiply this one. We are going to multiply this one to 1 pesos and 50. Okay? Because based on the given, we are going to pay additional 1 peso and 50 centavos for every kilometer in excess of 4 or a fraction of kilometer in excess of 4. So, 1 peso or 1 pesos and 50 multiplied by 1, that will be 150 plus 9 pesos, which is the base fare, and that will give you 10 pesos and 50. So, if you are going to travel 5 kilometers or less, but not less than 4, you have to pay 10 pesos and 50 centavos. How about for 6? Okay, so for 6, there are 2 additional kilometer, and same goes with it is just like the second one, where if it is 5, 2 will be multiplied to 1 pesos and 50, and the product 3 will be added to 9 to obtain the fare whenever someone ride a jeep and travel 6 kilometers. And for 7, we have 3. So 3 will be multiplied to 1 pesos and 50 and add it to 9 to obtain the fare. Now, for x, let us just say we do not know yet the value of the number of kilometers. Okay, it is simply x. So if that is the case, as you can see, to obtain 1 from 5, we just subtracted 4. Same goes with 6 and 7. We just subtracted 4 to obtain the number of additional kilometer. So if we have your x as the number of kilometers, we just need to subtract it by 4 to obtain the additional kilometer. So this x minus 4 will be multiplied to 1 pesos and 50, and then the product will be added to 9, so to obtain the fare. Now, I use the ceiling function of x minus 4 because whenever it is in between, or the number of kilometers is in between an or two integers, we are going to consider it as a whole, or the small portion will be considered whole. So if the case is 4.5, that will be 4.5 minus 4, that will be 0.5, and 0.5, its ceiling function is 1. So 1 will be multiplied to 150 plus 9 to obtain the fare. We can also rewrite it this way. 1 pesos and 50 multiplied by the ceiling function of x plus 3. Because the ceiling function of 4 is 4, okay, multiplied by 150, or negative 4 multiplied by 156, negative 6, 9 plus negative 6 will give us positive 3. So we have here 3, and we have here 1 pesos and 50 multiplied by the ceiling function of x. We can, or in other words, the mathematical model for the problem is given by, we have here the fare, okay, it is 9 pesos if the number of kilometer x is greater than 0 but less than or equal to 4. It means if the number of kilometer is in the first 4 kilometers, but if it exceeds 4 kilometers, which means x is greater than 4, we have to follow this rule to compute for the fare. Okay? You can also rewrite this when it is in simplified form, like, or you can also rewrite this as 150 multiplied by the ceiling function of x plus 3. Okay? Those two are just similar. the latter is just the simplest form or the simplified form of this. But this one or this answer is also considered correct because those two are just equal. Okay, so that will be the first, or that will be all for the first part of the video or of this lesson, representing real life situation using functions including piecewise function.